So hello guys, I am back with another new problem. The problem number is 3824 on late code, and let's just jump into the question. What this question says. The question is about the minimum key to reduce array within the limit. So let me explain you that in easier way that what this question really says. So in question you have given an array and you have to find an integer key such that on subtracting, let me explain you with an example. Suppose here is 375, and if you choose any positive integer k and reducing with that k value, what you will get? See here, 3, 7, and the 5. So after reducing 3 from each and every element of that array, you will get 0, 4, and 2. And in next operation, if you again do this, means if you again subtract 3 from the 3 from all positive element, what you will get? You will get, sorry, not from everyone. You have to not subtract from everyone. You have to subtract from each element one by one. So we first reduce the first element of that array. Now going to reduce that second element of that array. So here it will be like this. Here value will be this. After second operation, now in third operation, it will be this. Hmm. In fourth operation, it will look like this. In this way, we have to perform. Basically, we have to subtract that integer value k from each and every element, such that our all elements of array become less than or equal to 0. So for example, if you performed in one operation, you can just reduce the one element of that given array. So you have to perform number of operations. So suppose you have performed count operation. If you have performed count operation, then there is one more condition that the count should be less than or equal to the k square. What does the k square? So what does this k is? The k is the positive integer which you have just chosen. Hmm. So after reading this question, what the first thing I get in my mind is that basically we have to reduce each and every index element. So and let's just see the constant. Here the constant is given that the array length will be up to 10 to the power 5, and and each index element can be up to 10 to the power 5. So it's a huge constraint. Mm. So the basic idea of this question was, actually I have solved this question before, so I know the idea. So basically the way to solve this question is to perform binary search on the given array. So let's see how I'm going to apply this binary search. Means is binary search technology means how to just see how I'm going to apply this binary search here. Suppose we are going to take suppose this will be the test cases we have to solve. This will be the last test case we are going to handle. It will be like this, and it will be around 10 to the power 5, 5 times. So maximum it can be the maximum value which we can get in array is this. So in this case, what we can do? So on summing of all element of that array, we can get around 10 to the power 10. So if we sum these all values, means here I have taken here I've taken 1 lakh, here I've taken 1 lakh, 10 to the power 5, 10 to the power 5, and if I sum all these 10 to the power 5s, what I will get it we will get around 10 to the power 10. So we have to reduce approximately 10 to the power 10. Hmm. So for reducing 10 means the basic condition is that we have to reduce by dividing each element hmm, with k, and it should be less than or equal to k k power square. This is the basic condition. So what does the here after applying some mathematical calculation, we can get easily the value of k. So from here the value of k will be 1/3. So k will be 1/3 of this. Hmm. You know 1/3 of this 1/3 of 10 to the power 10. So from here we can get after calculation. I think it will be around 220 2,200. So just for it will be around to 2,160. So for just for our just for our just for our just for just for our sake we have to take 2020 just to escape from those eight cases. So what we are going to do? So I am going to do binary search from 1 to 10 to the power 5. This is because I will search in between. Yeah, I will first find the mid value. So that I will, and then after that I check that mid value is going to whether it is going to perform that k operation and it will satisfy that given condition all condition or not. If it is satisfied, then we'll move to left side. So let me first write the code. After that I will explain more clearly. Into solve. Here I will take in the array. Hmm. And the left value is equal to 0. Sorry, not 0. It will show divided by 0 error. Not 10,000. We have just calculated it was around 2,200. It will cover all the cases. And now when r value is greater than equal to 0, these are the cases. Hmm. What we have to do? We have to find the mid value in binary search. L plus r minus l divided by 2. Divided by here we have find mid value. After that we have to check if it's satisfied. If we perform operation hmm, is satisfied, then we have to check. We have to give this array as well as this value mid value. If it is satisfied, then what we have to do? We have to just increase the if it satisfied the mid value, then we have to substitute the r is equal to mid minus 1. Really? And if it doesn't, then we have to increase the mid left value, which will be mid plus 1. Then at the end, here I have taken the end last true value. It will always return. It will always return. It will what it does is it always return the correct answer. If it's satisfied, then update the last two value to the mid. It will and this will be going to be your answer. At the end, we have to return last two value. Now let's define this is satisfied function. Boolean type because it is returning a boolean value. So I am writing this. So here I can initialize count, and I have to check whether all these conditions is satisfied or not. Means all this given condition on the description is satisfied or not. So I have iterated over each and every index element. What I have done, I have just updated the count value that array of height divided by k is equal to 0. If there is a remainder, if there is a remainder, we have to add that to. Hmm, sorry, if there is remainder, then add one extra because it takes some one more operation to reduce all elements. So at the end we have to check at the end we have to check if count is greater than equal to k square then we have to return false else we have to return true. You can understand what I've done. I just iterated over each and every index of that given array and just counted how much operation you need to reduce that 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 index element. And and I've just stored in count value, and after I check that whether it is less than k square or not. If it is k square, then it returns true. And after that, I already explained how the benefits work. And at the end, what we have to do to just return the before that, what we have to do, we have to sort this array. For applying the binary search, we definitely have to sort this array. For giving it into this binary search function, and after that we have to expect it will. Oh, sorry guys, my internet is gone. Guys, due to some technical issue, I'm not able to submit this question because there is something issue in my laptop. Don't know what happened. The Wi-Fi. I can just disappear from my. I can type. So for now, I think my code is correct, and I have already done this problem before. So it is correct code, and you will not face this problem if you apply this way. So basic idea, I think I am able to clear you the basic idea about how to solve this problem. So this is enough. This is enough from my side. And for today, that's it. And we will meet again tomorrow. For now, have a good day and spend a good time with your family. Goodbye.